A square is both a rectangle and a rhombus at the same time. So we have this Venn diagram here showing you how it is we have this set of parallelograms. Some parallelograms are rectangles, some parallelograms are rhombus. If it's both a rectangle and a rhombus, it's a square. Now remember, not every parallelogram is a rectangle or a rhombus. Some are just plain old rectangles, or parallelograms. Said that backwards. Some are just parallelograms. Now we do have a few theorems we can use to show a shape is a rhombus or a square. If the diagonals of a parallelogram are perpendicular, it must be a rhombus. If one diagonal of a parallelogram bisects the opposite angles, it must be a rhombus. If you have a parallelogram and the adjacent sides are congruent, it must be a rhombus. And then, well, like I said before, if a shape is both a rectangle and a rhombus, then it's a square. Now we can take that and we can apply that to a proof. Notice on our givens here, we're told LMNP is a parallelogram. So that's nice. We don't have to show it's a parallelogram. We're told angle 1 is congruent to angle 2. And we're told angle 2 is congruent to angle 6. So we want to show it's a rhombus. Well, really, all you have to show then is we have to show angle 5 is congruent to angle 6. So let's write down our proof. So we know LMNP is a parallelogram. We know angle 1 is congruent to angle 2. And we know angle 2 is congruent to angle 6. Well, if we think of, well, let's put our given in here. Well, if we take a look at our parallelogram, angle 1 and angle 5, they're alternate interior angles because of the parallel lines. So I'm going to think I'll write that. So angle 1 is congruent to angle 5. Why? Because they're alternate interior angles. And since we know angle 1 is the same as angle 2, and angle 1 is the same as angle 5, so angle 2 is congruent to angle 5 by transitive. And since angle 2 is congruent to angle 5 and angle 2 is congruent to angle 6, angle 5 is congruent to angle 6 by the transitive property. Now notice we have two pairs of angles that have been bisected along the diagonal. That's the definition of a rhombus. So LMNP is a rhombus. What's the reason? Well, that is if one diagonal bisects a pair of opposite angles, then that shape is a rhombus. Pause the video and see if you can answer example 4. Now, example 4, we're told the shape is a rhombus. No, take that back. We're told it's a parallelogram. And we're told AD is congruent to DC. Oh, that's one of our theorems. That is, if you have a parallelogram and adjacent sides congruent, it must be a rhombus.